Uh, Good morning. Welcome to my neighborhood. This is at 1. And today I'm gonna make a comparison between two things which I think are the same, um, mazes and sets of proofs. I think that those are connected. So I am thinking about two different algorithms. One that solves mazes, so it'll figure out like maze is a set of graphs that are kind of like parallel, I guess you could say. Um, this isn't a perfect description, but it has a beginning and end, and certain rules on which directions you can go in. Usually, it's like forward, left, or right. And you have like zero. So we have one or two or three choices for which uh, direction you want to go in. So that's the maze. And a maze solver would be something that finds a path from the beginning to the end. So that would be a maze solver. And then I think let me play with it here. Okay. Um, Automated theorem prover. Um, Basically you input a statement and it tells you whether it's true or false or neither, I guess. I've never seen an automated theorem prover do neither. They usually just they usually say yes, it's a theorem. They deny that it's a theorem, or they say it's computer's taking too long, so it's not telling them. So they have to kill the uh, test. So okay. So a proof. What is a proof? What is a proof? A proof is a path from an axiom to a terminal vertex. So, for example, the solution to a maze is a proof because it's a path from the beginning, which is the axiom, to a terminal vertex, which is the theorem. And then, so we have here, this is kind of an oddity. Kurt Gödel thought of proofs as observations, and we're observing something when we prove. So that's kind of interesting. What is a proof anyway? A proof is a sequence in which every term in the sequence is either the output of an inference rule applied to previous terms of the sequence, or it is in the set of axioms. So that's it. Also, the proof is a path and a digraph that has the vertex with more input edges than any other. That's the theorem. And it's the solution to some types of two-dimensional mazes. So, I know that was a lot of information to grasp, but I could go slower. In fact, if someone has a request, like any part of this, and if you want me to go into more detail, I can. If I run into a wall, I'll give you a reference. I have an abundance of references on formal systems. All right. Well, I guess that's it for tonight. Good night.